Assalamualaikum and hi. We are from Group 6 and we will talk about the summary of carbohydrate, catabolic metabolism. So, let's have fun today. First, we will go to the glycolysis process. Glycolysis location was at the cytosol and it can happen with or without the oxygen. Glycolysis consists of 10 steps that are divided into two phases. There is energy investment phase in step 1 to 5 and energy payoff phase in step 6 to 10. And the final product of the glycolysis is 2-pyruvate, 2-ATP, 2-NADH plus H plus and 2H2O.
1 molecule of glucose is broken down to 2 molecules of pyruvate, and as you can see, step 1 until 5 is the energy investment phase because we use ATP at step 1 and 3, while the energy payoff phase was at step 6 until 10 because we produce ATP at step 7 and 10. Although we produce 4 ATP, the only net gain of glycolysis is only 2 ATP because we already used 2 ATP at step 1 and 3.
Next is Krebs cycle. Krebs cycle, also known as tricarboxylic acid cycles and citric acid cycle, and they are a biochemical pathway. Krebs cycle used to generate energy through oxidation of acetyl-CoA, synthesis of NADH, and production of amino acids. So Krebs cycle will take place in mitochondria in eukaryotes and cytosol of prokaryotes. For the allosteric activators in Krebs cycle is calcium and ADP, while the allosteric inhibitors are ATP, NADH, succinyl-CoA, and citrate. The production of Krebs cycles are 6 NADH, 2 FADH2, 2 ATP, and 4 carbon dioxide. So for 1 glucose will equal to 2 pyruvate, and 2 pyruvate will equal to 2 acetyl-CoA.
So this is the steps in Krebs cycle that you need to remember when it involves 8 steps. The products of Krebs cycle are 6 NADH and 2 FADH2 will be used in electron transport chain to form ATP. Citrate is Krebs starting substrate for making oxaloacetate. It's the easiest way to remember the Krebs cycle.
Okay, next we will learn about oxidative phosphorylation. Oxidative phosphorylation is a formation of ATP by using energy derived from the redox reaction of electron transport chain. It consists of two processes, which is electron transport chain and chemiosmosis. It's located in inner membrane of mitochondria. Please remember that 1 NADH plus H plus will produce 3 ATP and 1 FADH2 will produce 2 ATP. Okay, next, electron transport chain is a series of electron carrier molecules embedded in inner membrane of mitochondria that carry electron from NADH and FADH2 through series of redox reaction to synthesize ATP. So this is a structure of electron transport chain. There are 6 steps in ETC. The first one is the pathway of electron from NADH plus H plus in complex number 1, and then the pathway of electron from FADH2 in complex number 2. Step 2 until 6 is the pathway of electron from NADH plus H plus and FADH2 in ubiquinone, complex number 3, cytochrome C reductase, complex number 4, and the last one is oxygen.
Next, the process which involves the ATP synthase is called chemiosmosis. Chemiosmosis is the movement of hydrogen ions from high hydrogen ion concentration to low hydrogen ion concentration through ATP synthase to catalyze the synthesis of ATP from ADP and inorganic phosphate. So this is the structure of the ATP synthase. It consists of 3 components. The first one is rotor, which spin clockwise when hydrogen ions or proton flows through it down the proton gradient. The rod will connect the cylindrical rotor and the knob. It will spin to activate the catalytic site in the knob. So this one is the knob. it contains catalytic site that joins inorganic phosphate to ADP to make ATP. The chemiosmosis process is related to the electron transport chain. So this site is where the electron transport chain occurs, while this site is where the chemiosmosis takes place. The accumulations of H+ in the intermembrane space creates a proton gradient across the mitochondrial membrane. That means there is high concentration of protons in the intermembrane space compared to mitochondrial matrix. The proton gradient form causes protons from intermembrane space to diffuse back into the matrix of mitochondria through ATP synthase. ATP synthase uses energy from the flow of H+ that catalyze the ATP formation from ADP and inorganic phosphate. As those protons come across the ATP synthase, they build back up on the mitochondrial matrix, which means there will be a high concentration of proton in the mitochondrial matrix compared to intermembrane space. In this case, the electron transport chain will take place and the process is repeated as long as NADH and FADH2 are being shuttled from the Krebs cycle to the electron transport chain.
Fun fact: catabolic exercise are aerobic or cardio exercise. They may include movements like running, swimming, and biking, where you are in a steady active state for a relatively long period of time. According to the American College of Sport Medicine, it's aimed to get at least the following amount of aerobic exercise each week. That is 150 minutes of moderate intensity or 75 minutes of regular intensity. This is usually broken down into 3 to 5 days of training. As a result, they may help you to build a healthy heart and lungs, but they may also cause you to lose body mass, both muscle and fat. So if you want to lose some weight, you can do the catabolic exercise, but if you want to gain your muscle, it was a suitable exercise for you to do. Next, we have a YouTube link that will make you guys easiest and fun way to remember glycolysis step.